Hello everyone, welcome to Scalar Academy's YouTube channel. So myself Vamsi, in this tutorial we will be learning about recursion. Followed by we will be solving a few easy level problems using recursion topic. And coming to prerequisites, there are no big prerequisites. If you know some basic stuff like loops, and if you know about functions like how to make a function call, how to return from a function, that's it. Okay, so you can start with this video without any fear. This is entirely an beginner video. Okay, so but at the end of the video, I am pretty much sure that you will be good at recursion topic and you are able to solve some easy level problems using recursion. So let's get started. Oh, wait. So before starting, we do have a few formalities to do so. First one, if you are visiting channel for the first time, please don't forget to subscribe. If you like the content, please hit that like button up. If you have any questions or video recommendations that you would like to hear from Scalar Academies, please let us know in the comment section. So now let's get started. Let's say recursion. So the definition of recursion will go something like this. A function which calls itself is called recursion. So what does it mean? Let's take an example and we'll see. So let's say you have a function, okay, let's say fun, and you are getting some input here, okay, and you have some tasks to execute. Let's say you are executing all the tasks here. It's a body of a function, and right before exit, like returning from the loop or returning from the function, or while returning the function, if you make a call to the same function again, let's say, okay, yeah, so again you are making a call to this function, right? So again it will perform all these tasks, and again it will reach this a particular line. Again it will make a call by and doing n minus 1. So at the end of the day, you are after performing all that task, you will this particular line of code will get executed, and you will return from that particular loop, sorry, return from that particular function, right? So I'm doing this task for the repeated times, right? So like infinite times. So how to stop? Yes, there will be some base case where that will be the end thing that we are solving. Okay, let's say, let's take an example, okay, small problem, and we'll see how that recursion works and all. So let's say you will be given an n, okay, you will be given an n, and you are requested to print all numbers, okay, starting from that n, right? So here I have given n as 5, and you are requested to print 5, 4, 3, 2, 1. So a 1 will be the last number. Okay. So let's say you have given n equal to 10, and then you will start from 10, 9, goes on something like this, and you will reach till 1. Okay. So please pause the video for a while. Just think about how it will be solve this problem using a recursion. Okay. Now let's get started. So let's take a function. Okay, let's take a function and a name of print number, and it will be taking your n. Okay, fine. Okay, so I have given n as 10. Okay, so I have given n as a 10. Now what I need to do? First I need to do print that 10, right? So print n. So now after printing 10, what I need to print? I need to print 9, right? So it means that if I go here, I can come here and I can print that 9. So what is a 9 in terms of 10? It's a just an 10 minus 1. So if we generalize it, it will become 10 minus 1. So we'll call a print a num n minus 1. Okay, fine. So it will come to 8, then it will come to 7, it will come to 6, 5, 4, 3, 2, or 1, right? So after printing 1, it will go to your n will become 0, right? Your n will become 0. Now let's say what to do. Whenever you have reached that n is equal to 0, you need to stop your iteration, right? You need to stop your recursion call. You can't, you need not to call the other things, right? So now let's break this problem something like this. So until your n greater than or equal to 1, you need to do this task, right? Everyone agrees that. So think. First you will be doing 10, then 9, then 8. So whenever you reach that 1, n is equal to 1, you will print that and you will go and your n will become a 0. Then you will come back to this loop again. So then you will check the condition. What is that condition is? If n greater than or equal to 1, you will do this task. Otherwise you will come out of that particular condition and you will go, like you will just return from your function to the main, so wherever it has been called, right? So sorry, it is not an int, it's a void. Okay, and now this is a done, right? So let's see how this has been called. Okay, now let's see recursion tree. That, like, recursion tree is something like that, how this function calls has been called, so that you can easily like visualize that stack. Okay, okay, let's say first you have called a print 10, right? From that print 10 you have called a 9. From that 9 you have called 8. From that 8 you have called 7, then 6. So goes on something like until print 1. So after print 1 you will come print a 0 and you will stop here. This is the end point. This is your end point. Okay, now how to analyze and time complexity of a recursive like algos. So basically it's a little trickier, okay, so than a usual analyzing the complexities of for loops. Okay, now let's see total how many recursive calls has been done. So a 1, 2, a 3, a 4, 5, like goes on something. So for 1 it will be 10, right? For 1 it will be 10. So you have done at most 10 calls, right? So 10 calls to print all the numbers. Okay, so how many numbers you need to print? It's a 10. So you are making 10 recursive calls. If I have given n equal to 100, now just tell me how many recursive calls I need to do. It's 100, right? So the complexity of this, if we generalize this both things, you can come to one conclusion. What is that conclusion? So the time complexity of this particular will be a big O of n. What is this n? The number which you have given. Okay, makes sense, right? Now let's move on to next other problem. Like it will be an follow up for this particular problem. So what we are doing here, we have given an n and you are starting from that number and you are printing all that numbers are till you reach that one. But in this particular, now you are doing something like this. Okay, you will be given again n. Now instead of starting from the 10, you are starting from the 1. Okay, let's say so so for this, when like you have given n equal to 10, you have to print 1, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so please pause the video for a while. Just think about how it can be possible. Okay, now let's see. So let's write the same code that we have written for a particular number. Okay, like earlier. Okay, so void print a num int n. Okay, so if n greater than or equal to 1, we are doing count n and l. Then we are doing a print a num n minus 1. So this is what we are doing earlier. But now if we do something like this, we'll get a 10 first, then followed by 9, 8, something like that. But we need it in a reverse order, right? So we need to traverse till the end. We need to print 1, then we need to print 10 at the last. So what we can do? Simply what we can do. First, before printing, we'll call n minus 1. So what you have did, you are given a print 10. Then first you are making as a print a 9. Okay, instead of printing the 10, you are calling a print a 9. Okay, then you are calling a print 8, then 7. So goes on like that, print 1 at the last. So what are you making here? So you are, so whenever you reach 1, your condition like so then it will reach to print 0 next. So whenever you reach here, your condition gets failed. Okay, now you will go back to this call. So you have finished this particular call, and what is the next statement you are doing? You need to print that n. So what is the n here? Your n is 1. So if you print n here, you will get your answer as 1. Then you will go back to 2. Okay, right above that thing. Then you will get a 3 because a 2 has been called. Then you are going back and you are printing the next line. So that next line is account n. So C out n. So you are printing that 2. Then 3, 4, 5, 6, 7, 8, 9, 10. So after making 10, it will directly go to the main function, like wherever it has been called. Okay. So this works. Okay. So what we need to do? So instead of writing this here, we'll just copy. Okay. So we'll just copy. Okay. It's doing a print a num n minus 1. Okay. So again, the condition is same, right? So we need to traverse till the n till n or greater than 1 or greater than or equal to 1. Whenever at the time of you have reached to 0, you need to stop over there and you need to return from that particular. So you need to go. You need to simply jump to the next line. Okay. Okay. That's all. Another is simple problem using recursion. So now the problem statement will be given something like this. So you will be given an n. Okay, let's say you will be given n equal to a 5. And you need to print a factorial of that given n. Okay, let's say the factorial of this particular input is 120. So factorial of 5 is equal to 130, right? So how this has been solved? So 4 into 4 into 3 into 2 into 1. This is how the formula of factorial works. Okay. So we have solved two problems, but you are not able to figure out why we are solving this problem using a recursion. So the best use case of a recursion is you are given a big problem. Let's say you have given one big problem here. You don't know, obviously you don't know the solution for this problem. Okay, so what you will do? So you will make this entire problem into small chunks. But one thing that you could have identified here is you know the solution for this particular. You know the how to solve this a smaller problem. There you found that there is one relationship between this particular smaller problem and this next bigger problem, and also you have found an relation between next bigger problem, something like that. Okay, so this entire big problem is depend upon this, then this, then this. So this is the one of the best use case. So like if you found an problems like that, then you can apply an recursion over there. Okay, now let's see by using this a trick how we are solving this a factorial of 5. Okay, so we have a given asked you to find a fact of 5. Now let's write this 5 into 4 into 3 into 2 into 1. Just answer my question. So this is n. Okay, fine. Now what is this? Can I say they say something like a fact of 4. Now let's say you don't know the fact of 4. You don't know the fact of 4 as well. So what is a fact of 4? How can you write it? So 3 into 2 into 1, right? So again this is n. Just assume this is n. And what is this? It's a fact of 3. Agrees that? Again you will write it as a 3 into 2 into 1. So you know this as a n and this is a again fact of a 2. So this is goes on something like that. What is the smallest sub problem that you can solve for a factorial, or the problem like what is the smallest sub problem that you know the answer for? So we all know that truth fact of 0 or fact of 1 equal to 1. So you like the if the constraints or constraints were given something like this, 0 greater than or equal to n greater than or 10 power 8 or 7, then you need to handle for n equal to 0 as well. In sometimes they will be giving you 1 greater than or less than, so this. Okay, so in both cases you need to handle the 0 and 1. So this will be your base cases. Now you found that 1 is the smallest sub problem that you need to solve for factorial of finding a factorial of a given n. Okay, now let's see. So we have generalized that. So finding a fact of 5 is fact of 4. Okay, so again you will be writing for fact of 4. It's an a 4 into fact of a 3 again. So it's a 3 into fact of 2. Again it is a 2 into a fact of a 1. Again it's a 1 into fact of a 0. And you can't go beyond that 0, right? So you know that that is the smallest sub problem that you are going to solve, and you know the fact that fact of 0 and fact of 1 equal to 1. Okay, so what you will do for this, simply you will return a 1. Okay, so now it's a 1 into 1, it's a 1. Who call this particular call? That is this fact of 1, right? So you will simply return 1 to this. Now it's a 2 into 1, it's a 2. Who call this particular call? It's a fact of 2, so you will simply return 2 over there. Now it's a 2 into 3 into 2. So who call this? It is fact of 3, so you will simply return 6 here. So it's a 4 into 6. Who call this? Fact of 4, will return a 24 here. Then it's a 5 into 24. Who call this? It's a fact of 5, it's a 120. So you found the answer. Let's see how to code our approach. Okay, so again I request you to code try it on your own before so seeing the solution. Okay, now let's say we have a function called a factorial, and you will be taking n as your input. Okay, okay, so what is the generalized formula? What is the relation that you have identified in this entire tree? So here, so what is this in terms of n? What is this in terms of n? This is a n, this is a n minus 1, right? And now again you are making fact of n, right? So it's n, since you are making a fact, you will be treating this 4 as a n. So again it's a n, and this will be n minus 1. Again you are making a call to fact of 3, so it's an n, so n into n minus 1. So if you generalize this, it will be n into fact of n minus 1. This is your generalized formula or a recurrence relation as well. Okay, now let's see. So what is the formula that you have identified? So we will make an call like a simply a return n into a factorial of like n minus 1. Okay, we'll simply return n into n minus 1. So whenever you have call factor of 5, you will simply return 5 into factorial of 4. Okay, again you are making a call, it will go to top and it will solve for 4. Then again it will go to top and it will solve for 3, then something like that. So at the end of the day, you will be returning this particular thing. Okay, now as I said, you will be having one base condition. If you don't have any base condition or stopping condition, it will get into the infinite times of recursion. So then after some time, it might get overflow, your stack will get overflow. We'll come to that, what is that stack. Okay, so it will get overflow, and then you will end up with an error. Okay, so what is your base condition? Like base condition will be the smallest problem that you are going to solve. Okay, so here that smallest problem that we are solving is if n equal to a 0 or n equal to 1. In that case, what you can do, you can simply return your or like simply return 1. But in all other cases, you will be doing n into factorial of n minus 1. Okay, now let's try to analyze the space complexity. Let's try to analyze the time complexity and space complexity. Let's see. So first you are making a call for fact of 5. Then you are doing 5 into fact of 4. Okay, you are calling fact of 4. So again you have making one call. Again you have made another call for 3. Again you have made another call for 2. Again you have made another call for 1. Okay, so after reaching 1, you will stop here. Now, tell me how many calls we have made. Yes, a 1, 2, 3, 4, 5. Okay, it's a 5 calls. So finding a factorial of 4 involves 5 function calls. Okay, simply like if you have given n is equal to 10, what how many calls you will be requiring? 10 calls, right? So if you generalize that calls like so if you know how to analyze and complexity of loops, right? So how we are analyzing the complexity of loops, it's simply how many times you are iterating through that loops, right? Okay, if you have given and like for I is equal to 0 to n, so you are iterating to n times, so you are saying that your complexity is big of m. Okay, so here as well, so you are making a 5 calls, right? 5 times you are iterating through into that particular recursion function, so it means that you are making a 5 calls. So you are running that loop for the 5 times recursion function for the 5 times. So your complexity will be generalized to big O of n. Like whatever the number you have given, you need to traverse you need to make and reversion calls for that many times. Okay, so since it is that, you can say that your time complexity is big O of n. And what is your space complexity? Here to a store to store all your function calls or recursive calls, you will be using something like a stack space. Okay, stack space, we'll come to this. And what is a stack space? Okay, let's say what is the first function call that you have made? Say factor of 5. Then from factor of 5 you have made factor of 4, then 3, then 2, then 1, right? So since this is a stack, like the functioning of a stacks, that nature of stack will be first in first out. Like whatever comes first, it will go out at last. Okay. So let's see. Okay. So it's since it's a first in, a first out, what came first into the stack? It's a 5. So since a 5 has been entered into a stack for the 5, it will go in a last. Then it's a last before that, since like that. Okay, so first this came at the last, so since it came last, it will go out for the first. Okay, so you will find an answer for this. Okay, then it will return 1, then your job is done. Okay, then it is out 2, so like your job is done here as well. Then it's a 3 into 2, you have written n into fact of n minus 1, right? So it will return 6, then this it will return 24, then this it's a 120. Okay, so here to generate this like whatever stack space. Okay, stack is also an kind of memory that you are storing all your recursive calls. So say, but one thing that you need to be very careful is the difference between stack space and the extra space. So since you are, did you define any like stack manually here? No, you haven't. Since you haven't declared it on your own, it is not come under extra space. It will be called as an auxiliary space. Okay, auxiliary space. So you need to be careful with that term. Okay, so but yeah, since you are saying since is even auxiliary space is also memory, you can say that so I'm not using any extra space, but since I'm using a recursion topic here, it will be using big O of n auxiliary space. Okay, so if you said this term or this topic in the interview, yeah, so they might ask what is the difference between extra space and the auxiliary space. So before going into interview, just be careful about, you might have done a proper research on these things. So let's solve another problem using recursion. So the problem statement is given something like this. You will be given an n. You simply need to return nth Fibonacci number. That's it. Okay. So let's say if you have given n equal to 6, your output should be equal to 8. If you have given n equal to 0, your output should be equal to a 0. If you have given n equal to a 7, your output should be equal to a 13. Okay. Now let's pause the video for a while. Okay, please try to think of what is a Fibonacci number, how to solve this problem using a recursion. Okay, so let's see. So let's say first we'll see what is a Fibonacci number series. Okay, so let's say before starting, okay, so Fibonacci series includes two base values, let's say 0 and 1. From these base values we will be building our entire series. Okay, let's say, so what is a 0 plus 1? It's a 1. What is a 1 plus 1? It's a 2. What is a 1 plus 3? 2 is a 3. What is a 1 plus 2 plus 3? It's a 5. What is a 3 plus 5? It's a 8. 5 plus 8, it's a 13. So next 31, it's a 34. It goes on something like this. Okay. Now let's try to point out the indexes of this series. Okay. So the indexes of this series will starts with a 0. Okay. Oh, this is a 0 n. Okay, let's say if your n is 0, you will be simply returning this value. And this is a first, this is a second, and this is a third, this is a fourth, a fifth, sixth, a seventh, eighth, a ninth, goes on like this. Okay, now again pause the video file. I have given in a hint what is a Fibonacci series. Okay, now try to think. Okay, so at least try to think of in a loops manner, try to solve this problem. Okay, now let's see. Okay, let's see. So if I have given five, ask you to find Fibonacci of 5, what would be your reaction? So we'll say like simply, so add Fibonacci of 4 and Fibonacci of 3. Your job is done. It's as simple as that, right? So if I ask you to find Fibonacci of 5, what is the like you need to add a simply need you need to add previous two numbers Fibonacci number, right? So since I given n is equal to 5, so what is the previous two numbers? It's a 4 and 3, right? So what is the fourth Fibonacci number? It's a 3. What is the third Fibonacci number? It's a 2. So we will simply return 5 as your answer, right? That is as simple as that. Now the problem starts here. Okay, so now tell me, so you don't know anything, like apart from Fibonacci of 0 is a 0, Fibonacci of 1 is a 1, you don't know anything. And you know that through that by using, like if we add previous two numbers, like previous two Fibonacci numbers, we will get our current Fibonacci number. So you know these two facts. Okay, on these two facts you are building your entire logic. Okay, now tell me, so do you know the Fibonacci of 4? Don't know. We only know 0 and 1, right? So we don't know Fibonacci of 4. So what we will do? Again you will do, now your problem got reduced to finding the Fibonacci of 4, right? Now what you will do? So you will write Fibonacci of 3 plus Fibonacci of 2. That's it. Now again your problem has been reduced to finding the Fibonacci of number 3. Okay, so Fibonacci of 3 is equal to Fibonacci of 2 plus Fibonacci of 1. Right? Now again your problem has been reduced to finding Fibonacci of 2. Fibonacci of 2 equal to Fibonacci of 1 plus Fibonacci of 0. Done. Now tell me, do you know the Fibonacci of 1? Yes, you know the Fibonacci of 1. What is that? It's a 1. Now you will simply add 1. And like what is the Fibonacci of 0? Do you know? Yes, you know, right? So it's a 0. So you will do 1 plus 0. It's a 1. So now you know the Fibonacci of 2 as well. It's a 1. We'll simply return here. Now find, in the process of finding the Fibonacci of 3, you made a call to Fibonacci of 2, right? And you got 1. Now tell me, what is the next call? That's a finding Fibonacci of 1, right? So what is the Fibonacci of 1? It's an 1. So now tell me, you will simply add 1 plus 1. You will get a 2. Now you made a call this. You have completed these calls. Okay. Now you will simply return a substitute 2 here. Now your problem got reduced again. You are making a call to Fibonacci of 2. Okay. Now tell me, so already we have found that, so like I'm not drawing the entire tree. I will do that later. Okay, just as of now, be in a flow with me. Okay, so I will just simply do 1 here. So it's a 2 plus 1, it's a 3. So I know Fibonacci of 4 is 3. Now again I will make a call to Fibonacci of 3. Now what is the Fibonacci of 3? It's a 2. So it's a 3 plus 2, it's a 5. Okay, so my answer is 5. This is how you will be solving your Fibonacci number. Right. So now pause the video for a while. Okay. Think of an what is a generalized formula, like what is a recurrence relationship between these calls, and what will be your base cases, right? When to stop this recursion kind of stuff. Okay. Now let's start. Let's say, how can I write the code? Let's say I'm assuming I have a function called a fib, and it is taking accepting one parameter. Let's say n. Okay. So whenever I'm making call, I will simply return something. So what is that something? Let's assume here a 5 is n. Now tell me what is the 4 in terms of 5? What is the 4 in terms of 5? It's just a 5 minus 1, right? Now tell me what is this 3? It's a 5 minus 2. So it's a 5 minus 2. Since a 5 is n, how can I write this? It's a n minus 1 and this is n minus 2. Right. So now my problem is yeah, I'm substituting n as 4. Now it will be n minus 1 again, and this is n minus 2. So can I say that the recurrence relation that I am looking for is fib of n equal to fib of n minus 1 plus fib of n minus 2? Can I say something like this? Yes, I can say that, right? Now, whenever I made a call of finding a Fibonacci number, I will simply return fib of n minus 1 plus fib of n minus 2. Job done. Job done. So, I will make an recursive calls again. Okay. Now, let's try to draw a tree for this, like how recursion calls make. Okay. Let's say, first I have taken a fib of 4. Okay, fib of 4. So what is the thing I will be making now? So first I will make fib of n minus 1. Since it's an n is equal to 4, you will make a fib of 3, then fib of 2. Like 2 calls, okay? Now from fib of 3, we will make a 2 first. Okay, so from fib of 3, you will make a 2. Now your n is a 2. You will again go here and your n is a 2. So again you will make n minus 1. So you will make n minus 1 is at 1. Okay. Now tell me. So whenever n is of 1, you will simply returning 1, right? How we are. So here this will be your base case, right? So if n equal to 0 or n equal to 1, if n is equal to 0 you will simply return 0, if n is equal to 1 you will simply return 1. So can I say that whatever your n is you will be returning that? Yes, so I will simply return, yeah, okay. So if your n is equal to 0 you will simply return 0, if your n is equal to 1 you will simply return 1. That's it. So on this note I will return here 1. That's it. Now I'm done with n minus 1. Now I need to make a call for n minus 2. So since my n is a 2, I will make a call to n minus 2. 2 minus 2 is a 0. So what I will return? It's a simply return a 0. Done. So now what is the addition of this? 1 plus 0 is a 1. So I will simply return 1 here. Now I made n now for n is equal to 3, I made an n minus 1. Now I made to make n minus 2. That's an 2. Sorry, n minus 1. Sorry, fib of 1. Okay. So whenever my n is equal to 1, I will simply return 1. So what is the sum here? It's a 2. So I will return simply 2 here. Now like I'm done with n minus 1 part. Now I need to go for n minus 2 part. Okay. Now again, so I am currently standing at n is equal to 2. I know? I know. So I will simply make another call. So since n is equal to 2, what is n minus 1? It's an 1. So what is the fib of 1? I will simply make an return as of 1. Okay. I will simply return 1. Now again, so I'm done with n minus 1 part. Now I'll go to n minus 2 part. Sorry, it's at 0. Okay, fib of 0. What is the fib of 0? Again, it's a 0. So what is a 1 plus 0? It's a 1. So I will simply return 1 here. So what is the sum of these values? It's a 3. So I will return 3 from, if I make a call fib of 4, I will simply return 3 as my answer. Done. So I hope you guys have understood. If not, I recommend you to pause the video for a while. Okay. Now try to rewatch it again before jumping into analysis of an these algorithms, because it's very important to understand how that recursion calls has been made. Okay, how we are returning from that function calls. Okay. Now let's see time complexity of this approach. For every recursive call, how many possibilities are there? How many function calls we are making? We are making two function calls. Can I say that? So for finding, whenever I made an fib of 4, I made an two calls. One is fib of 3 and one is fib of 2. And whenever my n is 3, I made an again two calls. When again I made an two calls. So can I say that if my n is a 6, my n is a 6, I'm making something like this, a 2 into 2 into 2 into 2 into 2. Can I say that? For every possible number, I have two possibilities. Okay, for every number I have two possibilities. Okay, either n minus 1 or n minus 2. So these are the two possibilities. So I'm going both of the ways. Okay, that's why for every number I have two possibilities. Okay, that's it. Now if I generalize this, how can I write this? It's a 2 power 6. Right. So what is this 6? We are searching for n is equal to 6. Now tell me what is this 6? It's a simply 2 power n. So can I say that? Finding n is equal to 6, or if n is equal to 6, we are making big O of 2 power n function calls. Yes. Can I say that? Like, yes, right? I can say that. That's how we have solved this, right? Now, what will be our space complexity? Now, tell me, so are we using any extra space here? So, did we define any space? And no, big no. We are not using any extra space. So, extra space equal to constant. Okay, it's a constant. Now, tell me, so there is something like auxiliary space for recursion, right? Auxiliary space for recursion. Tell me. So, for this, so let's say we have a stack. We have a stack. Now tell me. So first we'll store f of 4, like fib of 4. Then from that we'll go to fib of 3. From that we'll go to fib of 2. From that we'll go to fib of 1. Now tell me. So from whenever I made a call of fib of 1, I will simply pop this out and return a 1. Right. So I'm done with this part. Now I will again come to here. I will make a call to this part. So I will can say again fib of 0. So whenever I made a fib of 0, I will again simply return a 0 and I will pop this out and I will go here. I'm done with this function call, right? So I made a both calls. So I'm done with this fib of 2. I will simply go up. Okay, I will simply go up. Now tell me. So for this fib of 3, I'm done with fib of 2. Yes. And I need to do fib of 1 again. So fib of 1. So I will return 1. I'm done with this call as well. So since I have completed both calls, like both possibilities, I will simply return this, strike out this as well. Now I'm done with this as well. So for this, now again, I will go to fib of 4. Okay. So for fib of 4, I will, then I will go to here. So I will make a fib of 2. Then for like while solving fib of 2, again I'm making fib of 1. So I'm done with this. I will go here and I will again make a fib of 0 function call. I will make out 0. Now I am done with this. I am done with this. I am done with this. Now tell me how many function calls that we have stored in our stack at max. Can I say that? So first we have a jump here. First we have jump here. Right. So from here, from then 1, 2, then here. So 4 calls. We have stored 4 calls, and then slightly we are popping out the calls from the stack. Right. So we are done with stack and we erase that. Then again, after going here, again we have stored this and we have done. We are whenever we are done with that, we have popped that out. So can I say that? Can I say that? So at most, at max, so I'm storing the max height of an particular tree, right? So this tree. So what is the maximum height of this tree? It's a 4. 4, right? So 1. 2, 3, 4. So I'm making that many calls. Like I'm storing that many calls at a time. So again, I'm whenever I'm done with that particular call, I'm popping that out from my stack. Okay. So can I say that finding a fib of 4, I will be using at max of big of n, like n space. Yes. So then I can say that my auxiliary space is equal to big O of n. Done. So your space time complexity is a big O of 2 power n, and your auxiliary space is a big O of n. And whenever I am talking about extra space, it's a big O of 1, similar to constant. Okay. Yes, so give it a try on your own. So try to write a code. Okay, try to submit your answer either on interview bit or any other coding platforms as well. So let's solve another easier problem using recursion. So this time the problem statement will be given something like this. You will be given a string s, okay, s, let's say OMC, and you simply need to print. Okay, you simply need to reverse that given string. So if you reverse this string, what will be your output? Your output should be ISMAV. So don't forget, you have to do this in place. You are not allowed to do take any extra space. Okay, you have to do it in place. Means you have to do within this like S string itself. Can't define any other new string like a temp or result, something like that. Okay. Yes. So please pause a video for a while. Come up with a solution. So yes. So it's okay if you're not able to figure out this solution. I'm here to help you now. So let's start. Okay. Now let's elaborate this example and we'll see. Okay, let's say we have our form C. So if we reverse this, like this is our original. If you reverse it, what will it become? It will become I S M A V. So please observe this string, like please observe like original and reverse strings. So what is your observations? So I can clearly see that this first element has been like first character has been swapped with like exchanged their places, right? So it went to last and this came to first, right? Yes, do you agree that? Yes. Now let's see. So what about this? So again, these both have been exchanged their places. So S and A. Now again, what happened? So here, since it's only the value it left with, so it will simply put that or job done. So let's suppose, okay, so this is our odd length string, right? So let's suppose we have taken an any even length string, let's say a scalar, S-E-R. Okay, so this is our original string. So if we reverse it, okay, so what we do, we will be taking considering S and R. Okay, we'll swap first S and R, S, R. Then we'll swap C and E, E, a C. Then we'll swap A and L, right? We are left with that. That's it. Our job done. So now again, please pause the video for a while. Think about the solution. Yes, you might come up with a solution. I know. If not, let's see. Okay, so let's say a scalar. Okay. So we'll take a two pointers. Okay. So first is at this, let's say start, and this is at beginning, let's say end. Okay, start and end. So what we do? So we'll simply need to swap the both R and S, right? We'll swap the both R and S. Okay, so will these R and S. Then what we need to do? Then what we need to do? We need to move towards, like we need to move our start towards a next element. It means that we need to simply move our start to here. Yes, agree that? Yep. Now what we need to do here with the end? So we simply need to move our end to a down towards left, right? So it will be here. Now again what we need to do? We need to swap this E and C again. So we'll replace E here, then we'll replace C here. Now again what we need to do? We will increment our start and we will increment our end. So will be our start pointing to this and our end pointing to here. Now again what we do, we simply swap these cases. So S, L and A here. So what is the result? So now, like what happens if we swap again? So we are done with the swapping, and now what we need to do? We need to increment and decrement our value. So if we increment our pointer, it will get S here, and if we decrement our n, it will be here, right? But if I again swap these values, it will get to its original, places, right? So let's see. So A and L. So again we are swapping them for the two times. Okay, so first time we have swapped, and we got changed those values. Again if we swap them, it will get to its original spaces, right? So we don't want to do that. So what we need to do now? So one thing here is, we have reached till the middle. Okay, it means that we started from the start and end. Okay, with the two pointers. Every time we are moving closer, 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 closer. So it, by the means, whenever we met at middle, it means that we have covered all the elements. We have covered off elements with the S. We have covered off elements with the A. So whenever we cross our paths, it means that we have crossed our middle. So whenever we cross that middle, we'll stop over there. Okay, so that's the thing. Okay, that's the thing. So how that code looks like. So even if you can observe, so every time we are repeating this process until our S less than E. So here, so if you see, so here S is here, let's say indexes 0, 1, 2, 3, 4, 5. Okay, so S is pointing to, S is start. Our start is at 2 second index, and our end is at third index. So it's a less. So whenever we change our increment or decrement our values, it will be S will become a 3, E will become 2. So this is a not valid. Okay, we need to stop there. So it means that we have increased, like start has been incremented than our end. So we just crossed our path. So we'll stop there. So let's write code for this approach. Okay. So I'm assuming that I have a function called reverse a string. Okay. For that, my inputs are string, and I used a pointer. Okay. So int yes, int end. Okay. Okay, int s and int n. So if, so first I need to check whether a start is a lesser than end or not. Okay. So now tell me what to do if that condition is a true. So if that condition, like our start is a less than our end. So if that is the case, we'll simply swap s of s, like start, and s of e. Sorry, it's a string, right? So sorry. str. Okay, so str of s and str of e. We'll swap those. Then what to do? So we just need to increment our s and decrement our e, right? So again we need to repeat the same after incrementing and decrement as well. So yes, we are solving a recurrence. So we again call that a reverse string, and we'll increment, like we'll pass a string as it is. Then we increment our start by 1 and we'll decrement e. Done. So whenever we cross our paths, so whenever we cross S and E, we will simply get out of that loop. That's it. So like that recurrence. Okay. So if I print count after this call in my main, like str, it will get reflected. Okay. So because I've used address, I've passed here address. Okay. So please spend some time understanding all these problems and try to write code on your own. Okay, please give it a shot. Like pick up some easy level problems either from interview bit or any other coding platforms. So see whether you are able to solve the problems, or whether able to sync up with like whatever we have learned. Okay, so please try easy level problems. Okay, so that's all for this video. Thanks.